Back in my days, a chat system was something which was very complicated. Sure, tools like Yahoo Messenger and Skype brought this technology to the masses. But even then, there were so many little steps. You had to first sign in, it would then connect you, you would wait for your friend to come online, and then you could start chatting. But in today's world, chat has become an indispensable part of our lives. Talking to our friends, just talking to our customer care services, even on websites, you have chats everywhere. So it becomes very natural to understand how does a chat system even work. So in this video, we'll try to explore a little bit on it. Hello friends, welcome back to my channel. To keep things granular and easy to understand, I have divided this topic in two separate videos. In this particular video, we will go over some of the basic concepts and what does a high-level design look like. What is the requirement of a chat system and what can we do to overcome some of these challenges. In my next video, I will be actually talking about how do you scale it for 1 million users and what kind of technologies you can have such that scaling is possible and you can account for such a high traffic. Now, before we go into a chat system, I just want to let you know that in the system design series, we have covered a lot of topics. We have went over some of the very basic fundamentals. We learned how to create all of these diagrams to understand how these components connect and how they talk to each other. After that, we have started to discuss some of these optimizations. How do you make your system faster? How do you make everything efficient? And combining all of this, we have also looked at some of the very important designs that you encounter in your day-to-day life. For example, a news feed, a local delivery system, a cloud storage service. All of these are very essential to understand. So if you're looking at all of this for the first time, I would highly recommend you to check out my previous videos also. Otherwise, let us dive into a chat system and start off with the very basic requirement that we have. When you talk about a chat system, what is the most basic criteria? What do you need? The first and the most basic thing you need is there should be a user A and a user B. They have to chat with each other and they could be in any part of the world. The most basic requirement is that you will have some kind of a service in between them that is going to store all of the messages received from user A and then transmit it to user B. And this communication should happen in both the directions. This is what composes a chat system, correct? And you may say that, okay, this is how a mail system also works. You send a mail and then the other person receives it. But you want to happen this in real time. That is what makes a chat system different. Although, when you look at a chat system in today's world, in the current scenario, there are a lot of concepts behind it. There are a lot of features. So when you talk about designing a chat system in an interview, there can be a lot of different requirements. For example, your chat system should have a one-on-one chat feature. It should also have a group chat. You can have a mobile app, you can have a web app, and you also have to scale it to a large number of users, correct? Along with all of this, you can have features such as uploading attachments, and you can have broadcast messages as well. The list just goes on. There are additional features also where you can implement a voice call and a video call. But that is beyond the scope of this video. We primarily want to focus on a chat system and what are all of the components behind it. And if you think about it, a one-to-one chat is just a special feature of a group chat. In a group chat, you are sending your message to a lot of people. In a one-to-one chat, you are just sending your message to a single person. So it is just a special case. We are also going to look a little bit into how you can support multiple platforms. And you also want to look at the online presence of a person. Are they online? When did they last go offline? Have your message been already read? All of these things. But before going into all of that fun part, we first need to understand the very basic concept. That is, how do two people actually connect on the internet? And what are the common communication techniques between them? If we have to broadly categorize these communication techniques, you can have polling, you can have long polling, and you can have WebSockets. Now, all of these methods are used to communicate. But you must understand the limitations of certain methods before we arrive at a method that actually works for us. For example, polling. What happens? In polling, you will have a client and you will have a server. Polling simply means asking from the server. So the client will keep on polling the server, hey, do I have any new messages? Do I have any new messages? And every time the server will say no, because no new messages are coming to the server. So let us say this is your timeline. Now the client starts to ask, hey, any new messages? No. Any new messages? No. Let us say after some time, there is a client that actually sends a message. So this client will send a message to the server. And what will you do? In your timeline, the client will again ask, hey, are there any new messages? This time the server will say yes, and you will get your new message. And what will happen next? This client will keep on pinging the server. Are there any new messages? Are there any new messages? This is a very basic implementation of a chat. Yes, you can implement it for experimentation, but you are creating so many connections every time. You create a connection and then you close it. You create a connection and then you close it. Ideally, your chat will work. You will be able to communicate. And for small systems, you won't even notice the lag that is happening. It will work perfectly. But we want to scale to 1 million users. You can easily see this is not going to work for us. So how about we start removing some of our bottlenecks? If you notice, we have very small lived connections for each of my requests. What could happen if I have a longer request? And that is where long polling comes in. Long polling simply means that I will ask the server, hey, do I have any new messages? And then the server is gonna wait a certain amount of time before telling me that, hey, there weren't any new messages. So try to understand it like this. Again, we have our timeline over here. I have my client and I ask the server, hey, are there any new messages? Instead of replying back immediately, the server waits a little while. It will wait a certain time and it will see, hey, did I get any new messages? If yes, I will return it. Otherwise, I will say, no, I didn't get any message. This time could be 5 seconds, it could be 3 seconds, anything. And then once again, when your client says, hey, are there any new messages? Let us say before this time, a client sent a message to a server. Your server will now respond with a yes, and your client will receive the message. And once again, this will go on. The server will keep on looking for new messages. And at the very end, it will say, hey, I did not receive any more messages, and it will close the connection again. So we were able to solve one of our problems. We don't have a lot of connections now. But what just happened? Our connection duration increased, and we still haven't received a real-time response. We are every time opening a new connection and closing it. Opening, closing, opening, closing. So that is so many wasted cycles. If you want to try relating this to a real-life scenario, you can think of it like two people in the world. They send a handwritten mail and then the other person receives it. The first person will keep on checking their mailbox. Hey, did I get a new message? Hey, did I get a new message? Hey, did I get a new message? And we can assume that, okay, person B after 3 days decides that, okay, I will reply. They send a message again. And on the 4th day, you go and check, hey, did I get a new message? And you get it. This is what is happening. Now think about a walkie-talkie. How does that work? It is live and it is bi-directional communication. What do? You have your walkie-talkie and there's a push to talk button. You press that button and then you communicate your message. What happens? Instantaneously, your message is delivered to the other person, correct? So what did we just do? We established a live bi-directional stream between two people. And that is exactly the foundational concept of a WebSocket. A WebSocket means you open up a connection between two people. And now, as soon as a person A sends a message, it is immediately received by person B. And now a person B wants to send a message, it will be immediately received by person A. This is happening all of it in real time. And that is why a WebSocket is a perfect choice when you want to design a chat system. So let us look at the scenario once again. I have my client over here and let us say this is my timeline. Now, instead of asking the server again and again for new messages, what you will do is you will do a HTTP handshake with the server. Basically, you are asking the server for a WebSocket from its available pool. You will say, okay, I need a WebSocket connection. This server is going to acknowledge that request and it will open up a WebSocket for you. This WebSocket is now open and you can easily send and receive messages via this WebSocket, and it will stay open. Now what happens? Similarly, on the other side, you will have another client who is going to request the server, okay, I need a WebSocket. The server acknowledges the request, and now this WebSocket is also open. In your timeline, now you have two WebSockets open for both of the clients. That means both of these clients have established a bi-directional message channel, and it literally behaves as a walkie-talkie. As soon as this client sends a message, this message is instantaneously delivered to the client. And that is how two people can keep on talking with each other. Now, you might be wondering what happens in an app like WhatsApp. I have hundreds of contacts. So, will I have hundreds of WebSockets? No. What is going to happen is you usually have one WebSocket, and the client or you will set up different messages via this WebSocket. One message could be directed to another user, one message could be directed to third user, one message could be directed to the 100th user. So this one WebSocket is keeping all of your connections alive. And the way your mobile operating systems work, Android or iPhone, even when you close the app, this WebSocket remains open. You might have seen that, right? If you force close an app and if you open it again, it takes a little bit time to load, because that WebSocket connection is actually being implemented again. You are again making a request to give you that WebSocket. Whereas if you minimize your application, that socket remains open and you receive your messages instantaneously. I know that you will still have a lot of questions in your mind, like what about notification system? What if the person is offline? How does everything happen? And just wait a little while, things will become clear to you. Up till now, we have just discussed the major component that enables you to have a real-time chat system. There are a lot more concepts that you should be aware about. For example, what is a stateless service and what is a stateful service? Because understanding them is very essential for a system like chat. Up till now, whatever we have been designing is mostly a stateless system. A stateless system simply means that each request that the user is making to the server is independent of the previous request. That means in each of the requests, you do not remember anything from what happened previously. In each request, you will again send the information about the user. This is the user, they are logged in, they want to do this. You do not want to relate it to a request that the user had previously sent. Yes, you might want to cache some of the results, but that is a different story. So basically, in a stateless system, all information is sent with every request. You don't have any session information, and this becomes easier to scale because that is what we have been talking about. Since the requests are independent, you can separate them into different services and spread them out across a lot of different data centers. So basically, you will have your user, you will send a request to the load balancer, and then you can split it as you like. Think what would happen for a stateless service in a chat system. You have your user, and then they connect to a load balancer. After that, you can have different services for you. An authentication service, that is actually logging you in. With WhatsApp, you log in via your phone number. For different chat messengers, you will have a user ID. You authenticate with your password. After that, you will have your user profiles. Every user has the different profile configured. And similarly, you can have group management also. Group management can be partially done on the client side and it can be done on the server side also. If you notice, for all these kind of requests, you don't need to remember what happened previously. Every time the user can make a fresh request. And that is how we have been designing all of our systems. This now brings us to a stateful service. And we briefly talked about it when we talked about WebSockets. In a stateful service, you remember what has already happened. So basically, you remember the connection or the user session. And this can happen across multiple interactions. For example, I have my chat service. User 1 opens a WebSocket to this service and user 2 also opens a WebSocket to the service. That is how these two users will communicate with each other. If you think about it, you are maintaining the ongoing context, you are establishing a real-time communication, and this inherently means that this becomes harder to scale. In such a scenario, you have concepts like a sticky connection or a smart connection by which you pause the service for a little while and then you try to scale it and then you will try to re-establish your connections. This is a little tricky, but we don't want to get into that. When you think about it, what other stateful services come to your mind? Try to think, what about live gaming? Two people are connected to the same session and they want to maintain what is happening. You have seen so many tools which offer collaborative editing. For example, a whiteboard, and two people can connect on it. So everything is happening in real time. Basically, any sort of apps that offer you collaborative editing or two people working on the same thing at the same time, that is where WebSockets come in very, very handy. And all of these are stateful services. These are harder to maintain and they have very specific use cases. So it is not necessary that you implement them everywhere. Chat applications are a perfect example where you essentially need them and you need them to make your application work. So up till now, we have combined a lot of different things. We have gathered a lot of ammo. Technically, now we can try to assemble all of the components and have a high level design. I have all of my stateless services available. My users can connect to a load balancer, and then I have authentication services, user profiles, group management. And all of these services can be connected to some kind of storage. So I can store my messages, I can store all my uploads. And then I have some stateful services also. For example, two users will open up a WebSocket to a chat service and they can chat. Also, you can have some third-party services like a notification service that will notify the users that, okay, you have some new messages available and hey, this person is now online. So now, if we try to connect all of these components, how will my design look like? I have my user sitting over here. They make an HTTP request to a load balancer, and this load balancer will connect me to all of the microservices that I have. I can manage my profile, I can manage all of the authentication. This all happens over here. Now, this user can also open up a WebSocket that will connect me to my chat service and the presence service. The chat service will help me to have a real-time communication between two people. Now you may ask, what is a presence service? A presence service can help you notify the status of two different individuals. For example, you might see that this person is online. The presence service is doing it. And yes, you guessed it right. It is once again a stateful service because the connection needs to be opened and it needs to stay open. Only then you will know the exact status, correct? Similarly, you can also have a different service available. That is your message read received services. That will tell you that, hey, this message was opened and it has been received and it has been read also. So all of these things which require a live interaction, they will reside over here. If you notice, both these microservices and these stateful services, they will be connected by my database layer. That is where I'm storing all of the information available. For example, when a user wants to send a message to another user, it is not necessary that you attach the image itself in the message. What you can do is, as soon as you see an image, just upload your image to your database. And whatever is the ID of that particular upload, just add that to your message and you can send it to the other user. Now, it is up to your client how to interpret that message. Your client will read the message. It will see, okay, I have information about an image. This client will go to the database, it will fetch the image, and now it will show up in your mobile. So what have we established? We have established a client that is managing all of the messages for you. This client is also managing all of the authentication, all of the profiles, and even the push notification service. This is how I have my client ready. So basically, I have completed a high-level design. The client can also manage groups for you. When you think about group chats, it is actually very, very clever. Let us say you have a group of 6 friends. When you send a message in the group chat, on the back end, it is possible that you send 5 different messages. In each of the message, you have a sender and you have a receiver. So in the receiver, instead of one person, you will have all of these 5 people. These messages are received by all of your 5 friends. And now it is the responsibility of the client how to interpret that message. As soon as the client sees, okay, this message has 5 different recipients, it means it is in the group chat. And that message will show up in the group chat instead of the one-to-one conversation. So all of this is actually very, very interesting. If you think about a general workflow, what happens as soon as you open WhatsApp? As soon as you launch the app, you will have your client and it makes a HTTP request to your load balancer. This load balancer will connect to all of the different microservices. It is going to authenticate you. It is going to update all of your user profiles. That is the metadata. So you now know, okay, this person has a new display picture. This is their new status. And this is the update that they have been doing. Also, it connects to a push notification service to find out that, hey, these are some of the older messages which haven't been fetched onto your client yet. Now, while all of this is happening, your client also opens up different web sockets for all of the stateful services. For example, the chat service, the present service, the message received service. These web sockets are now open and they are ready to communicate. As soon as you send a message, this socket is open and it will transmit the message. So all of these things are ready now. Your notification service has meanwhile fetched all of the older messages and you are going to see them in your client as well. I believe this gives you a good idea how a chat system works. And I would like to stop the video right over here because I want you to digest all of this information. Just take a moment and go through all of the concepts that we have talked about. Tell me all the questions that come to your mind. What is happening? How do you scale for a lot of users? What could happen if two different users are connecting to different chat servers? What about the global scale? You have a chat server in different region and you have a chat server in different region. Do these servers subscribe to Kafka topics? How does all of that happen? Just tell me all of this in the comment section below and I would love to discuss all of it with you. It would also help me to curate my next video such that I'm able to answer all of these questions and you have a satisfactory response on how this chat system is actually working. I'll really wait for all of your comments. And as a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This really keeps me motivated and I can make more such videos. Also, a huge shout out to all of the members who support my channel. You guys really keep me going. And as a member, you do get priority reply to your comments and early access to new videos as well. Stay tuned for my upcoming video. Until then, see ya.